Welcome back. As always, this is the Peggy Smedley Show. We are coming to you live from CES in Las Vegas, and it's exciting, all the things we've been talking about. And right now, I'm excited to have Vin D'Agostino from Renesas. He is here with me. Vin, welcome.
Thank you. It's always great to be here.
You are regular.
I know.
Right now.
I love this.
And now people are getting to see you live, so it's so exciting.
That's
right
a problem. I have
here
a face for radio, really.
Well, you do have a face for radio. We're talking about it. So we want to talk about all the exciting things that you think. I want your IoT perspective. You have been on this show so many times, so I know our listeners know you, and now our viewers are getting to see you and talk to you about it. What's your IoT perspective? What do you think?
You know, I've said to you and on your show before, I've said the IoT really is the IoTBD because nobody really knows where it's going and what it's doing, and we're starting to see some of that happen now. It's not just about connecting devices anymore, it's about all the things around that connectivity, working on the applications, sensor fusion, taking information from multiple things and creating a reality, an alternate reality to what's going on so you can make some decisions. It's about putting computing where you want. Now that the endpoints are getting more intelligent, you can do more things on the endpoint, some things in the gateway, some things in the cloud. That makes sense. You know, one of the challenges with IoT has always been, what happens when you lose the connection? Does your product simply stop working? Does it have less functionality? What happens? And we're seeing the distribution of intelligence now as people conceive systems such that users get more functionality out of their product when they don't have the connectivity that's consistent, whether it's a cell connection and they go through a tunnel, whether it's something in the home and you get out of range of a Wi-Fi, but your product still has some level of functionality, and that's some of the exciting things that I see going on the show floor. You know, I'm walking around, there's certainly a lot of ADAS stuff in the automotive section, but even as I walk through the rest of the show floor, there's things associated with ADAS-like technologies that are being used in other products. Little robots to play with kids and talk to kids, things to assess intelligence and help with learning. All the kinds of things that we have been looking at in various places are now being used in places that we never thought they'd be used before, and that's what I mean by TBD.
Let's talk about TBD. Let's talk about ADAS. For all these people who are hearing acronyms and they're like, I want to define those. Help someone understand, what do we mean by all of that? When they're trying to understand those things and they say, what does that mean to me? And these things, we talk about things, what does that really mean?
Right. So, I mean, ADAS is autonomous driving, and it's it's one step before we get to George Jetson's flying car, right?
Well, we're going to define that in a minute too,
okay.
But go ahead.
All right. And it's really about, and that's really about the interaction of data. I mean, if you think about what we do when we drive, or we do when we do anything, we are taking sensory information from our environment, we're processing it, and we're making decisions about how we interact with that environment. We now are starting to get in the sensor technology, in the computing technology to, we do sensor fusion all the time as human beings, and we don't think about it. We have smell, we have taste, we have touch, we have sound, we have sight, and we pull all that information together to create in our brains a reality that we can do some computing on and interact with that environment. And computers have never been fast enough to do that.
Not to interrupt you, but that sensor fusion is what sometimes why we as humans make mistakes when we drive.
That's true.
And that's why we talk about autonomous driving, is why we say a machine isn't going to have that problem.
Right. And if you can fool the human brain, you can also fool the machine, but maybe in a different way. For example, there's a great little thing down at, I think it's at Epcot, where you put your hand on this thing and immediately feel like you're burning your hand, but it's actually alternate coils of warm and cold, and the cold sensation next to the warm sensation makes it feel very hot, like salt can make things taste sweeter, right? And so that's the way you trick the human brain. With multiple sensors, you wouldn't be able to trick a machine for that, but you'd be able to trick a machine perhaps for something that was doing 2D imaging, where the brain, because of two eyes, would get 3D imaging, and you'd get you wouldn't get that false positive or that false data. So it's really it's not about, this is what I tell people about applying all new technologies. It's not about applying a new technology to the way you used to do things. It's about looking at a new technology in a new paradigm and figuring out a new way to solve a problem because you have a resource you didn't have before.
So when we're talking about these acronyms that we use out there, the reason we're doing this is to try to solve these problems because we have so many accidents, we have so many deaths.
Yep.
So when we talk about using LiDAR and ADAS and we're using all this stuff, is the reason we're doing this because we're seeing that we have to go to this next evolution to help our lives be better. Isn't this ultimately what the goal is for all of this?
It is, and better means different things to different people. I'm sure that people who love driving are totally against ADAS, right? And just like people who love cooking are totally against, instant food, but people who don't like cooking, instant food frees them up to do something else that they like. And I think it's really not so much it's about freedom, it's more freedom of choice, right? It lets you offload to technology things you don't like to do and onload to yourself the things you do like to do and are good at.
Well, your grandchildren, will not know what it's like to drive anyway. So will they miss ever being behind the wheel?
Probably not.
You will miss because you like having a sports car. If you can't drive, you're going to miss that.
Yes.
So I mean, where's the difference? I mean, there's things that we talk to people today, and I've interviewed that say, they never knew that experience that their grandparents had. So I mean, there are certain experiences we're never going to have. And I think that's what's going to happen, right?
My son Dominic is 14 years old, and when he was lobbying at 10 years old to get a cell phone, he was like, well, Dad, how old were you when you got your first cell phone? And I said, I was 27. And the look of horror on his face, I said, they didn't exist until I was 24.
And you described a brick.
Yes, and I described it. I actually have my original cell phone, and I showed it to him. It was a bag phone and he's like, you carried that around? I said, yes, I did. So you're right. There are, and there's a university in, Wisconsin? Every year makes a list of things that the incoming freshmen never knew or never lived without. And it's very interesting to see the changes of what people expect the world to be like and what it used to be like and what it will be like. I mean,
but these things though we're talking about, and I think they're exponentially happening now, and I think we didn't know that because we say, well, the next generation won't, but I think they're just happening quicker and quicker that things are changing. I mean, we wouldn't have thought a couple years ago that we would have Amazon Alexa or Google Home to be talking to us so quickly like we're using right now. And it's happening really, because just a few years ago, I was writing about people were freaking out about Big Brother. Yep. Well, we have to talk right now. AI is really taking over our lives in a very dramatic way. So when we look at these things, we're now not only talking about them being in our homes, but how they're going to be connected to our cars, and our cars are going to be intertwined with these. And those are things that you're working on when you talk about safety and technology in the cars and the things that you guys are doing.
Yeah, there's a lot of buzz around all of it. With anything new, there's buzz about it being good and being bad. With all the facial recognition, people worry about, where's that data going? Is my face somewhere in the cloud? Can somebody find it? Everyone's saying, I wouldn't have Alexa in my house because they're listening to me all the time. And you think about where all that data would have to go and who would have to parse it and figure it out.
Well, let's be honest. I mean, we have Amazon Alexa in our house, and sometimes it just goes on and we're like, we didn't give it the command to go on. So we're like, somebody's listening to something, but what are they actually listening to? They're listening to us talk about, hey, turn on Netflix. I mean, okay, they want to hear us say turn on Netflix, who cares? But the point is, on all of these things, a year ago, people were complaining it wasn't going to be in their houses. Now they've all let them in their houses, yep. And millions of devices are being sold. Now we're getting to this next evolution of exactly what it's going to be doing. Now we're talking about how we won't even have cell phones anymore because we're going to be doing things, and we were talking about swiping and pinching was so predominant a few years ago. Now it's all going to be voice in some way. It's going to open our car doors and things like that. I mean, we're really changing.
It's very much about the democratization of infrastructure. When I started out as a young engineer, we were laying out PC boards with tape and X-Acto blades and sending them off to chemical processes, and it was weeks, and you had, particular people laying out boards. Now you have PC board houses. You get online, you lay out your PC board, you have PC boards for $10 in 2 weeks. That process was months long and thousands of dollars when I started out. So the ability for anyone who has an idea to get online and try something. All of these platforms that are infrastructure, like an Alexa or a Google Home or a Cortana device, suddenly gives you an interface that you no longer have to necessarily write hardware, you can just be working on software. And the ability to do some of that really has democratized the technology, and which means more people are trying things and more people are doing things. And even if I, as a hobbyist or as a business, are not successful in what I've done, it may be a seed for somebody else to do something. You know, you look out on the show floor here, you and I know historically what percentage of this stuff actually hits the market for people, right. But some of these things just spark an idea in someone's head, and they go off and either solve a problem that they've been dealing with, wrestling with forever, and here's a new solution and I can finally get it done, or it sparks an idea for something new that does come to fruition. And that's the exciting part of it, really.
How complicated is it for a company like yours to be able to stay competitive, yet bring new product to market to meet the demands of what's happening at the rate and pace that it's changing?
Well, you know, that's one of the challenges of the industry, and that's why I think you see even a lot of consolidation in the industry. So Renesas made a decision a few years ago that it's not just about silicon anymore. It's about solutions, it's about applications, and that's one of the reasons that I joined the company was, you know, I was an applications engineer, designing products for people. I had my own business, as you know, and they wanted to get that expertise for how their products were used into the company to really change the way we manage the company, the way we manage new product development, and the way we go to market and change the culture. And so we are really dedicating time and effort to understanding our customers' applications and how the products are used. You know, my mantra from the day I walked in the building almost 3 years ago now was, it's not what our part can do, it's what our customer can do with our part, and getting people thinking that way. The whole semiconductor industry, and it's probably not just that industry, gets very excited about the thing that they do. They say, look what my part can do. And as a customer, I always said, it's not what your part can do, it's what I can do with it. What can I, you know, realize about it? And I think it's important that that people know that we have a handle on who we are and what our business really is. It's not about, we don't make devices that make your life better. We enable other people to make devices that make your life better.
And that's very
that's
critical
key.
Because those devices are getting smaller. The products are getting smaller, and you have to adapt to that and understand the needs of that, because for you, you have to be ready for that and those changes, and you have to understand your customers to be able to know how you're going to do it and the cost of bringing those down to adapt to those customer needs.
Yeah, it's I mean, there's lots of wearables, there's lots of discussion about what can we do to increase battery life for things that are small and handheld. We're seeing devices that we've never seen before, and they need to be powered, or they need to be powered from energy harvesting, and those all require new technologies. You know, everyone's investing in SOI, silicon on insulator kinds of technologies for their semiconductors. Most people are working on increased performance. How fast can my part go if I'm using an SOI technology and all that? We decided long ago, when we started on the journey of that, like everyone else, that everyone was going to be doing that. And for the greater computing space, that's really important. But staying true to who we are as embedded systems people, the embedded system interacts with the real world. The real world is analog. And so we made sure, as we developed our process, it was very analog friendly, it was very low noise. So do we have the absolute cutting edge clock speed performance? No. But in an embedded system where you need to mix analog and digital, we will have the best performing parts in that space because of where we invested in the technology. If that's not what you need, there are people who have faster parts for you.
And looking at that and looking at the embedded space, there are some very specific needs that have to be met. And sometimes
Yes.
people forget that because of what the embedded space is. Talk about the markets that is very critical in, because I think some people say everything's a digital world, but there are some very critical needs in an analog world and
Yep.
very vertical needs that must be met.
Right. You know, we say it's a digital world, and I've been hearing this for years. In fact, you know this about me. My degree is actually in small signal analog, and I couldn't get an analog job when I got out because everyone thought the world was going to be a resistor and a cap and digital after that. It still hasn't happened, and the real world is analog. So, you know, the challenges in embedded systems are, how do you quantize real world excitation of sensors, which is really what happens, and turn that into data that can be used. And it's really interesting when I talk to people who are doing cloud stuff.
Right.
When you talk to the people, I can even use my hands because we're on camera. So when you talk to the cloud people, they are very excited about databases and access and connectivity and AI and all of that stuff. And then as you get lower and lower down toward, and you cross this line into the real world that I call high fidelity data, then their eyes glaze over because they don't know anything about it. They are used to dealing with, when they cross that line, they assume everything is 100% correct.
Correct.
It's something
exactly.
that was barcode scanned in, something that was typed into the terminal, and you know, we all know the TV sitcom thing where somebody answers the phone and it's somebody trying to sell them a casket because the computer says they're dead. He said, I'm not dead. And he said, well, you're dead if the computer says you're dead. So that's that world. In the embedded systems world, we're dealing with the real world, and we get very excited about sensors and sensor fusion and how can we, you know, make sure we get the right data and decisions that we're making locally and controlling motors and heaters and all that kind of stuff. And then when we cross that line and talk about the cloud stuff, our eyes sort of glaze over. And we realize that as a company, and so we tried to put a foot in both camps. We have the Renesas IoT Sandbox that lets you play with our devices, but play with stuff on the cloud as well. We've made all those connections to all of the major cloud suppliers for every one of our device families, so you don't have to worry about that infrastructure. You can worry about solving your problem and getting a cloud expert to do that side, and we've already made the connection for you. So that's how we're enabling some of this real world interaction with our products and with partners. I mean, we are never going to get a bunch of servers and put them in a room and be the next cloud provider. That's not our business. We are the embedded systems people helping you with your computing task and your sensor excitation processing.
Now, haven't we seen what's happening in the market kind of come full circle now? We've all talked about everything going into the cloud. Now we're seeing some more things coming back where people say, I don't need to put everything in the cloud because I need to be able to manage a lot of this and understand that data that we're managing and being able to. So, I mean, where we always talk, everything has to be out there. There are some real companies that are saying, I've got to have this information here, readily available to me, and my partners that I'm working with have to be able to give me that information quickly. And that's what you're seeing, and goes back to that embedded world.
You know, connectivity, we won't even talk about the security part of connectivity.
We're going to get to that.
All right,
we're going to get
fine.
to that.
But when you look at that, the correct placement of computation is going to be key to making sure all of this works. You know, one of the big challenges that we still face, we talk about 50 billion devices, if every one of them takes 1/10 of a watt, that's 5 billion watts we have to come up with.
A lot of energy.
Right, lots of energy. So finding, and it's not just about low power processes, but it's even about architectures that allow you to do things more efficiently in those technologies. So the question is, do you do all the heavy lifting in the cloud, because that's powered already and running? You take some results and some inference engine and you put that locally. How much do you do on the edge? So, for example, let's say you are building a system that helps municipalities move traffic around by adjusting streetlights, by moving people like police and fire to where there are crowds to make sure that's right. So you have cameras set up everywhere, and maybe you can even do some recognition. You say, 12 people walk this way, 2 people walk that way, so there's 10 more people behind the camera. We may need more police, or we may need an EMT standing because we're now at a critical mass, or we're seeing all this traffic this way, let's change the traffic pattern so we can get people walking around. There's a lot of people walking here, so let's move cars to another part of the city. I mean, all of that's possible, but do you process that at the camera? Do you process it at the gateway? Do you push all of it up to the cloud and pay for all that bandwidth? And where's that bandwidth coming from anyway? And then you're processing it all up there. So there are people working on various portions of that problem. There's some people working on it in the gateway where they're tokenizing the information that they are processing locally and just pushing bytes up that say 3 people, 4 kids, 3 cars, 2 bicycles. There are people trying to do it right on the camera, and the whole bandwidth is because maybe the camera is connected through Bluetooth or even LoRa or something that's low bandwidth and you can't get the data through.
But because you don't need all of that. When we're talking IoT or M2M, whatever the acronym is for this industry, you don't need all of that. You don't need to go all the way to the cloud because you just don't need that, I don't want to say visibility, but you don't need that high speed, and that's when the embedded side of it. And now we go to that security side of it, now you're increasing the risk. depending on where you're storing that information.
Right.
And that's where we talk about, the bad actors, because now you're increasing the risk sometimes by putting it into the cloud when you don't have to, or you're making yourself more vulnerable. And that's the kind of things we talk about, because now a lot of the manufacturers or healthcare providers have a lot more risk and liability, and that's where you guys talk about, you look at what do they really need versus what they're being pitched that they should take.
Right, and the question is, can you do all that learning on the edge, or do you connect to the cloud for the learning? Let's say you're making, I don't know, a smart appliance, and you are at the store and you want to know, how much beer do I have in the fridge, or
everybody wants to know how much beer they have in their fridge.
Right? And so, can your local refrigerator train on every bottle and every can that you put in there, or do you train it on the cloud and bring information down that now it can recognize a can or a bottle in any orientation and tell you, right? So those are the decisions that are very architectural that will make or break products, not the technologies, right? The technologies are there. And when you look at using existing technologies to solve problems, you take a graphic processing unit and try to do embedded AI on it. And you can do it because it's blindingly fast speed. But the power requirements are tremendous. Other companies are looking at ways to implement technology that lower power. We have something that we've just recently introduced called a dynamically reprogrammable processor that is basically a combination of gate array technology and small little processors all working in parallel. And we have found that compared to doing EAI on GPU devices, we're using sometimes a tenth or less of the power to solve the same problem. But you need to rethink the way you solve the problem, because you're now solving it with this parallel processing instead of your regular algorithm just running blindingly
So
fast.
are you rebuilding that in a way for them to see what they're doing?
So we are, right? We're actually looking now at, because the tooling is going to be key, right? How you have user interface, how you have your compilers, how you look at a problem and divide it up into a way that you can do it in parallel. So again, if we just said, don't rethink your problem, this just runs faster, there's no real work to be done on the engineering side, but you're not solving the problem in a way that's sustainable. By rethinking the problem in a new paradigm, you suddenly have lower power, better performance, and the ability to solve problems that you weren't able to solve before.
So in that case, do you just take it to the edge, or can you take it both to the edge and to the cloud, or what way do you want
I think it's a combination of both. You're looking at four things. If you think about it very simplistically, you look at questions and answers, right? You either know a question or you don't know the question. You know the answer or you don't know the answer. If you know the question and you know the answer, you use a lookup table, right? If you know the question but you don't know the answer, you're doing machine learning. If you don't know the question and you don't know the answer, that's really deep learning, and that's where you might need more cloud resources to help you at least determine some of the answers or some of the questions that you can move it into the other paradigm. Right, and of course, if you know the answer and you don't know the question, that's jeopardy. So.
It's jeopardy. So then what do you think right now, looking ahead, what do you think we've got to think about in the Internet of Things? If you were talking to all of our viewers right now and our listeners, what do you want them to think about in the Internet of Things here?
So, I think I would say the Internet of Things opens up possibilities for collaboration of data that we've never seen before, whether it's between devices, whether it's among sensors to do sensor fusion, whether it's the collaboration of locally taken data and processed on the cloud or in the fog layer, in the the gateway, however you want to do it. But it's about enabling applications that you couldn't do as an isolated person. It's really the community of data and the community of processing, right? They say it takes a village to raise a kid. Well, it takes the IoT to do some of these new applications that couldn't be done with what I call point source computing, isolated devices doing one thing.
We have some consortiums. We still don't have interoperability. We're still not there. Are we ever going to get there?
I think we're going to get very close. You're seeing all kinds of technologies that never had the need to identify devices on a global basis, adopting things like IP addresses, stuff like that, MAC addresses, so that when you transform from one medium to another, you can maintain your identity of your data as it goes through and its source. And I think that's really important, right? If you think about all of these isolated communication channels were good for one thing or another. You use Bluetooth to connect your devices to the PC. You used long-range local stuff for very private networks. You used IP stuff for connecting your computers. Suddenly, the same piece of data could go through 4 of those things before it gets to a cloud place where it's actually analyzed and then pushed back to maybe another completely different device. So your piece of data that you took on an A to D converter on a little thing sitting on the table here might be transformed a dozen times. I think that's the key.
I'm not sure if we lost everyone with that because CES lost all our power. We'll see if we're still going or not. We might have lost our connection.
Okay.
We'll see here.
We'll see. Well,
we're still connected or we're not.
Okay.
And
that actually is a great lead into the next thing, which is looking at this technology. We also don't know what problems we will uncover. I was at a utility conference, and I was attending a session. They were talking about, won't it be great when we can tell 2 million refrigerators to turn off because we need the power? And I think about this and I say, my God, this is an industry that has sometimes people going into industrial parks and asking them to stagger when they turn on and turn off their air conditioning compressors because of the power glitches that it causes when everyone comes up and goes down at the same time. And now they want to turn off or on 2 million refrigerators at the same time. They're going to have a whole bunch of problems that they never anticipated with the ability to do this. And I think, inertia of the excitement could take us through some of those problems, but I actually think there are also some engineers and some non-engineers who, with common sense, who can anticipate some of these things and utilize technology to address those as well.
Well, Vin, we're out of time.
Okay.
Quickly, I want to thank you, Vin D'Agostino, Vice President I think you are Vice President of Marketing and Applications Engineering.
Yes.
Please tell our listeners and viewers where we can learn more about you guys.
www.renesys.com. It's our global website, and all of our products and technologies and applications are there.
I want to thank you as always for being with
us.
It's a
pleasure.
I love
Thanks
having
for
you
having
on
me
our
on the
show. And so we've got more to come. We want you to stick around. You can tweet at us at Peggy_Smedley, my personal account, or at ConnectedWMag. We're going to take a quick commercial break, but in the meantime, we want you to just send us anything you want, any questions. But as always, this is the Peggy Smedley Show, the podcasting voice of IoT and relevant technology. And remember, with great technology comes great responsibility. We'll be right back.